So, the truth table for conditional. We have A here, T here. And the truth table for conditional will tell us how conditional will operate in any possible circumstance. What do I write under T? True, false, true, false. What do I write under A, everybody? True, what am I doing? See, that's the trouble with trying to use a close. Yes, I sort of double it. All right, and what's the truth table of if A then T? True. False. True. True. All right, so we have memorized this one, I hope. This truth table tells us essentially how conditional operates. But there's another thing we can do with our truth table. And we've already seen this. In fact, we did this already, but it's worth doing again. We can prove what I call the Arrowsmith rule. And this is the reason why I use the letters A and T. What is the Arrowsmith rule? This is my stupid terminology. Yes. If you love Aerosmith, then you want these tickets is equivalent to a disjunction. What disjunction? Either you don't love Aerosmith or you'll want these tickets. Now, I said that they were logically equivalent, but how would you prove that they're logically equivalent? Yes, they would have the same truth values, and now notice, they have to have the same. Is it enough that they have the same truth value on the top row alone? No. No, that would just mean that they have that their truth values are consistent, that it is possible for them to be true at the same time. But we know that that's true for A and B and A or B. They're both true on the top row. But A and B is not logically equivalent to A or B because they have some differences in the truth table. So to be truly logically equivalent, they have to match up on every single row. If this has a true, this has to be true. If this has a false, this has to be false, and so on. So the way to prove that they're logically equivalent is to fill in all the truth values. Then what we've shown is that for every possible combination of truth values, they come out the same, which means they mean the same. There is no possible set of circumstances where they could differ in truth value, which we say means that they're logically equivalent. All right. Now, I could just work this out, slowly and ploddingly by saying, well, this is a disjunction. Not A is false, so false or true is true, and so on. Or I could take the quick route and say, I happen to know that this is a disjunction. How many times a disjunction is false? Just one. So let's work out where that is, and then I can fill in the rest as true. Well, when a disjunction is false? When they're both false. What line does that happen on? Second one, because T has got to be false and not A has to be false, which happens when A is true. So when A is true, not A is false, so you have false or false, which is false. The rest of the time, because it's a disjunction, at least one of them will be true. What have we shown? They are logically equivalent. Now it turns out there are other things that are also logically equivalent to these two. Is this one of them? You work it out. Because you already know the rule of implication. Yes, that is true. But you still have to check it. Because maybe the rule of implication is a lie. Now, once again, incidentally, are they logically equivalent? Yes. All right, once again, I'm going to be lazy. I noticed that this is a conjunction. What do I know about conjunctions? They're only true ones. When does that happen? When both conjuncts are true. What line is that going to happen on? Second line, because A is true and not T, and T is false, so not T is true. So that's going to be true and true, which is true, which means the negation of it is going to be false. The rest of the time this is going to be false, which means the negation of it is going to be true. What have we shown? What's that? They're logically equivalent. So, you can say the same thing in three ways. If you love Aerosmith, then you want these tickets. Either you don't love Aerosmith, or you want these tickets. You can't both love Aerosmith and not want these tickets. Which is what that says. Okay? So, logical equivalence. Now, let's complicate matters a little bit. Why not? Life would be boring otherwise. Oh, one more before we're done. Is that one going to turn out to be logically equivalent? Well, if you don't know, you better work it out. Well, it's a conditional. What do we know about conditionals? Only false once when the antecedent is true. The antecedent is going to be true when T is false, which happens here and here. And the consequent is, so the whole thing is false when the antecedent is true and the consequent is false. Not A, so that's going to be false when A is true, which happens here and here. So what row has them both what we want at the same time? That one, so that'll be where it's false, where the antecedent is true and the consequent is false, and the rest of the time, being a conditional, it will be true. Well, but we already knew that that was equivalent, because that these two are equivalent. Why? Because of, give me the word? Contrapositive. That's right. So this says, if you don't want these tickets, then you don't love Aerosmith. Okay. All right, let's make this a little trickier. I want you to work out whether or not these are equivalent. Why is this going to be more of a pain in the ass than what I've asked you to do previously?
Because you make a trip table twice as long.
What's different?
There's a third.
We have 3 letters. What difference is that going to make? Well, obviously I'm going to have 3 columns before that. Okay, so what? Just 1 extra column, right? Not much different. How many rows am I going to need?
8.
I'm going to need twice as many. I'm going to need 8. Why am I going to need twice as many? Well, I'll show you. Imagine that we just had B and C. Well, we know how to do that. That's like true, 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 false, like this. And you would only need you would only need 4 rows, right? That's what happens when you have 2 letters. We're used to that. But look what happens when you add a 3rd letter. to make sure that I've got all possible combinations, I have to have all of these for when A is true, but I've also got to have all of these for when A is false. So basically I repeat this again down here. True, true, false, false, true, false, true, false. Only for when A is false. So that's why every time you add a letter, you double it. If I had 4 letters, how many rows would I need? 16, because I'd have to have all these for when that letter is true, and all of those again repeated for when it's false. So notice that when you draw your truth table, it's basically you're doubling the number of truths. The last row, the last column is always going to be half truths, half falses, and you're going to double until you get up to that point. So it's going to go alternate, then double it, and then if we added another one, it would double it again. But if you do it that way, you will make sure that you get all possible combinations without really having to think about it. Fill it out. Josh, you look bored. Are you done? Did you use shortcuts? Yeah. Kind of? Well, in that case, you can work out. If you finish, work out this next one.
That's so cheating.
All right. For this one up here, what's the decision? Are they equivalent, yes or no?
Yes.
Yes. All right, I'm going to be lazy again, because that's the way I roll. And I'm going to notice that I can fill in a true here, and here, and here, and here, without even really having to think about it. Why can I do that?
Consequent is true.
Yes, because in this case, this is a conditional. What do we know about conditionals? They can only be false when the antecedent is true and the consequent is false. Well, here the consequent is true, so it's impossible for them to be false, so I can fill that in. I can also fill in true here, 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 and here. Why? Because the antecedent is false. And if the antecedent is false, you can't have true, false. Okay, so I've halved my work, at least. All right, now, I know that this can only be false when the antecedent is true. But it's a conjunction. The only lines where it could be true are the first two, because that's when A and B are both true. The rest of the time, it would be false. So that means, again, that I can fill in these. Because the rest of the time, this conjunction is going to be false. And so the antecedent of this conditional is false. And when the antecedent of the condition is false, the whole thing is true. So, that leaves this one. Well, A and B is true, so that means the whole thing is, the conjunction is true, and C is false. So that means the whole thing is?
False.
False. Alright, what about this one? Okay. Well, we know that the antecedent is true in this line, because it's A. So this has to be false for the whole thing to be false. But there's only one way for a conditional to be false, which is when the antecedent is true and the consequent is false. So that's the only line where that happens. The rest of the time it's true. So I know that this whole thing is going to be true except for that one line. Do the truth tables match? They do. So that is logically equivalent. What is the name of that rule? Exploitation. Thank you. Did you know this from a previous class, or have you looked at the cover of your book? If you look inside the front cover of your book, there is a set of rules that you will have to learn fairly shortly.
In the chapter too.
It's in the chapter, okay.
The 10 rules.
Okay, so you've looked ahead. All right, now this one.
Can't that be false?
Which one?
The third row from the bottom.
This one? Okay. Well, this one has to be true because the antecedent of this conditional is false. So if you look at the truth table for conditional, when the antecedent is false, the whole thing is true.
But then B then C is false.
That's true. But we have if false, then false, which is the bottom row of your truth table for conditional, which is true. All right, for this one, what are the words associated with this symbol? We call it logical equivalence, but, or the biconditional, but what are the logical words? If and only if. A if and only if B. This is A if B, and this is A only if B. So it's if and only if. Let's see if they're equivalent. Well, this one, what's C doing there? I only need this one. Basically, I screwed it up. Boy, I am on a roll today. They're equivalent. The only way that these are true is if both of these are true. You can fill that one out yourself. One last one. And this time I'm going to get it right. As God is my witness. All right, now, what I want to know is which of these two possibilities this is equivalent to. And guess what? I screwed up by not giving myself enough room. All right, I'm going to work backwards this down here. Okay, it's equivalent to one of them, but not the other. Work out which. Incidentally, I call this part of it, the first 3 columns where it's just the individual letters, I call that the scaffolding of your truth table. What is scaffolding in reality?
Piece of framework you put outside of a complete building, hold yourself up while you put it.
Yeah, you see it when they're doing building or fixing a building. It's a system of like metal tubes to support walkways. But what happens to the scaffolding when the building is done? They get rid of it. So the point of this is just something that will help you to fill in the truth table. But it's not really part of the truth table. You ignore it once you're done. Bless you. I'm not going to say it has any effect, but I don't have that power. Isn't there backing of that your soul was supposed to escape from your body when you sneezed and you had to bless it back in again?
Something like that.
No, your heart stopped beating.
Your heart stopped. I've heard both, yeah. And both of them are total bullshit, but still, we do it. Seems impolite not to.
Is that A plus B or
A plus B? I mixed in a bit of math.
A on the first one?
This one?
Yeah.
This is A and B or C. How is it that I can fill in these so quickly? What do they correspond to?
C value,
The value of C. So why can I fill these in?
because you have to have C which is true for there to be a truth value at all.
Yeah, because this is a disjunction. We need at least one of them to be true. But they're both conjunctions, so for this to be true, both parties have to be true. A has to be true and C has to be true. But here, C is false. So we know that's false. Well, never mind, this could be true. Well, except that C is also a part of that one. So if C is false, both of these are going to be false. So the whole thing is going to be false. So I can plug that in. Having done that, what do I already know? This is not equivalent to this. So being lazy, unless it says you have to fill out the entire truth table, which I probably would say, but as I didn't say it this time, I can move on to this one because I know that these two are not equivalent.
I think the instructions have said that it was one of them was equal to the first one. Couldn't you just say that it was equal? Because the instructions told you that one of them was
What? Oh.
No, like, would you even have to do a truth table for that one? Because they told you that one's equal, and since that one's not, then the other one.
Pretend I didn't say that. Say, no, what I said is one of them is equivalent, prove it. You don't just prove it by eliminating the other one. So how can I fill in those truths? What do they correspond to?
True C values.
The true C values. Why? Why will that mean that this is true? because this is a conjunction, so both of these have to be true. But they're both disjunctions, so if one of these is true, this whole thing will be true. If one of these is true, this whole thing will be true. Well, C is a part of both of them, so where C is true, both of them will be true. So I put a true value for when C is true. What's that? Time consuming. Well, let's speed through the rest of this. Here A and B are, A is true and B is true, so this whole thing is going to be true. But the rest of the time, at least one of them is false, so we're going to have falses. What have we established? These two are the ones that are equivalent. So A and B or C is equivalent to A or C and B or C. So notice this is a disjunction, but it's equivalent to a conjunction.